Hi, this is a quick video on data cleaning practices. So what we're going to do is we're going to clean up this data that is a left wheelpath mean right in column I. So you can see that I've got around 500 data points, which is really good because it means that I can use my filter to see what kind of errors I have in my data. So if I open that up, I can see that I've got some 0.999 and minus 888, and those are all measurement errors. And then I've also got no data values. I've got things that's not numerical. I've got the Excel not applicable error, and I've also got a few blanks in my data set. So what I'm going to do is I'm just going to make a list of the types of errors I have, and in that way I can handle them one by one. So the very first one that I'm going to handle is that not applicable error, because that tends to cause a lot of problems in Excel. Then I've got blanks. I've got non-numerical data. I've got minus 999. I've got minus 888. And I think that's the lot. Okay, so in order to handle the not applicables first, what I will do is I will write the statement if not applicable. Excel has got a function to actually handle that for you. And we refer to the value in column I. So if that is not applicable, then it asks us what do we want it to be. And I'm just going to put in there the word no data without any spaces. And then you will see that if I copy this down, then in every space where I've got a not applicable, it replaces it with no data. The one thing that I have to know though is that when I use this function and I had a blank cell, it returns a 0. Now, I don't want to handle my zeros as part of my errors because my data might contain zeros. In that case, for that reason, I'm just going to scroll down and I'm going to select only the blanks. And then I'm going to make sure that those zeros are regarded as blanks so that I can handle them individually and I don't necessarily assume that they have got a 0 value. Okay, so now that I've cleaned the not applicables out of my data set, I can go and clean all the other problems up in one go. So what I will do is I will use an if statement, and then I'm going to use an or statement, and then one by one, I am going to refer to my data problems. So I want to say, if this cell J13 is equal to a blank, or if J13 is equal to minus 999, or if J13 is equal to minus 888, or if my cell J13 is non-numerical. And in that case, what I will do is I will say is number, and I will test J13, of course, and I would say if that is equal to false, then that is a full list of all the possible problems that it might have. And in that case, I want to denote that cell as no data. Otherwise, what I will do is I will just return the original J13. So you will see now, if I copy this formula down, then no data remains no data. Now you can see that everything else that had a problem, like minus 999, minus 888, no data, and blanks, and also the not applicables, they are all now contain the word no data. So now I've cleaned up my data set, and I know that I've got no unnecessary blanks or anything in my data set. And what I can do is I can use this range now, or this population now, to create my frequency distributions and create my statistics. Okay, but I can go one step further if I wanted to. I can also cap this data between an acceptable minimum and maximum value. Okay, if I know the data, then I will know exactly what my minimum and maximum are likely to be. But in the case that I'm not familiar with the data, I need to go and do some investigation. And for that reason, I'll do some percentiles. So I'll take the 0th percentile, which will give me my minimum, and then the 10th, the median, the 90th, and the 1th percentile, which will give me my maximum value. So if I just calculate that with the percentile function, then I don't have to worry about using end down because I know that I've now filled in all the empty spaces with no data values. And then I can just lock my range before I copy my formula down. And that should give me my minimum value, my median value, and my maximum value. But at first glance, I can see that this maximum is unlikely. If you think that my 90th percentile is at 9.82, then it's unlikely that my maximum value sits at 10,000. Also, because I know the type of data I'm dealing with, it's very unlikely that I've got a rut of 10,000 millimeters. So very quickly, I can just scan down and see that that's probably a wrong value and that my real maximum sits at 18.2. It's not always possible to use the auto filter because sometimes the data set is too big, and in that case, when you use the auto filter, it would immediately tell you that it does not display all the possible values because there are too many. So in that case, if you just take a higher percentile, like the 99th percentile, you get a better indication of what the likely maximum value should be. So say, for instance, we could not see that the maximum value was actually 18, but we believe that it's very close to 13. And just to be sure, we will put the maximum value at 15. And the minimum value, we can see there that it is 1.4. So we can use a 1. And then if you copy that down, because the maximum and minimum is staying constant for the entire range, then I can go and calculate a capped value by further cleaning up this cleaned up number. So now first I'm going to find out if this value that I want to clean up is in fact a number. So I'm going to start with the formula if is number, and the one I'm testing is my cleaned up value. And if that is true, then I want to use the maximum of the minimum and my number, but instead of the number, I will put in the minimum of the maximum and my number. And then if that is not true, then what I'll use is the median. So if it is not a number, then I will just simply go for the median, which is 5.3. So you can now see that my 15.4 was capped at a maximum of 15, and therefore the final capped value is 15. And if I copy this down, wherever I had no data, where it wasn't a number, it returns the median value, which I ask for if I got a no number value there. So you can now see that if I look for everything that had a no data value, then you will see that it was substituted with 5.3, which is the median. And if I select all the values that's greater than the maximum, you will see that it capped it at the maximum value. And I didn't have any values that were lower than 1, so it didn't cap it at the minimum. It didn't need to cap it at the minimum. But now I've got a final cleaned up data set with default values filled in, and now I'm ready to do some graphing and carry on with that like that. I hope that helped a little bit.